Before we go any further, a preview of tonight's launch broadcast, starting with a presentation of Ariane and then a recap of recent space-related events and local news. A summary of the launcher campaign for Ariane Flight 128 with Ariane 505. Turning to our customers, we have the Asiastar film, followed by highlights of the Asiastar spacecraft preparation campaign. Next, the ISRO film for our Insat 3B passenger, and footage on the Insat preparation campaign. Then the Ariane Operations Division gives us an update on the operational and launcher enhancement situation. We follow the negative count through to Ariane 505 liftoff and the actual flight and orbit injection of the two spacecraft. Well, perhaps you could confirm that that is indeed an Ariane 5 launcher, Pierre Micheli, and give us a quick status report.
Yes, that is the Ariane 505 launcher, Simon, and all the launcher, payload and ground facility indicators are green for go, so it's looking good for liftoff in 30 minutes from now.
The launcher stands 52 meters high and has a liftoff mass, payload included, of 746 metric tons. The total performance requirement for Flight 128 is 5740 kilograms.
First of all, we have the Asiastar spacecraft, a satellite data digital radio broadcast satellite,
which will be placed into geostationary orbit. You see the track over the equator. The footprint covers practically the whole of Asia, and the satellite Asiastar will go into orbital station at 105 degrees east.
And the Insat satellite, a telecommunication satellite,
which will also be placed into geostationary orbit, again running strictly over the equator. The footprint covers the Indian subcontinent, and the orbital station will be at 83 degrees east. With 28.5 minutes or so to go until our launch window opens. All is green on the status panel, and we shall be keeping a close watch on these indicators at frequent intervals right through to liftoff. So explanations please, Pierre Micheli.
Yes, Simon. The Jupiter Mission Control is the control tower of the spaceport. Here we check the readiness of not only the launcher and the spacecraft, but also all the systems and ground facilities we need for the mission, like the telemetry, radar stations, telecommunications and weather conditions. The status of each launch authorization parameter is displayed on the panel you see on your screen, and all the lights are green, so everything is okay.
This Ariane launch broadcast is going out live to numerous sites in Europe, here in French Guiana, Washington DC, Tokyo, Japan, viewers taking the Space Night TV program in Germany, and our website visitors. And a special word of welcome to those of you in Bangalore and Washington DC on the satellite, at the satellite reception stations. We're now taking you on to visit to the Ariane 5 Launch Control Center, just 3 kilometers from the pad, to meet the launch site operations manager,
Nicole. The preparation of Ariane 5 is much easier than Ariane 4. First of all, on Ariane 5 there are not so many engines. Then, Launch Control Center number 3, thanks to its improved computer systems, makes it easier to monitor all operations. The 505 campaign is for me something of an apotheosis after 10 years operational experience, so I feel very excited and extremely humble about my part in this human and technological adventure.
We shall be taking a quick look into the Launch Control Center, the CTL, at frequent intervals as we approach time T and liftoff. So how many people are in the CDL at this present time, Pierre Micheli?
We have about 80 people tonight at CDL 3.
That is an average figure, or does it vary from according to mission configuration?
No, it's quite a normal number.
And we literally flash back the 14 kilometers to mission control to introduce to you to two more coordinator members of the Flight 128 team.
First, Rémi Cochet, the mission director from Ariane Space. His coordination task begins way back, well before the start of the actual launch campaign, and continues through the launch and end of the mission after the separation.
And next to him, the range operations manager, the DDO, Bertrand Moncuquet. He'll give us a handful of time checks before the launch, but immediately after liftoff, a steady stream of launcher status information. We'll tell you how he gets this at the appropriate time, when we've got through the flurry of the first couple of minutes of flight. This is the third Ariane launch this year, the third of a busy, heavily loaded manifest, with a total of 14 Ariane 4 and Ariane 5 flights scheduled for 2000. It's also the first night launch and the first dual launch for Ariane 5.
And we now have some film to give you a general picture of Ariane and Ariane space activities from the drawing board to liftoff. Status check, 20 minutes to go, and we are green.
And we'll be back after the break.
Versatile, flexible, powerful.
Attention pour le début de la séquence synchronisée, top moins 7 minutes. Donc les H0 moins 3 minutes, correct. Déroulement correct. À tous, du DDO, attention pour le décompte final. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, top. Allumage Vulcain. Allumage ERP. Décollage. Propulsion normale. Tous les paramètres sont normaux à bord. Trajectoire normale. All okay on board.
Ready to serve your business.
And in camera now, Jean-Marie Luton, Ariane Espace Chairman and CEO. He's heading the Flight Command Cell for Flight 128 here in Mission Control. The Flight Command Cell, an impressive title, Pierre Michele, but what is its particular function?
The flight command cell ordinarily has no more than a watching brief. It only becomes directly involved in the proceedings in the event of a major problem. For example, it becomes necessary to take the decision whether to stop the count or go for launch, and these can naturally include the customer or the customers. And we have some news brief of recent events for you now.
Coming up in just 5 or 6 seconds, our news items.
Ariane
Espace was strongly represented at the France-India exhibition held in New Delhi in December last. The participation emphasized Ariane Espace's long-standing association with Indian space activities in general. Ariane Espace also took part in the Cairo Telecom exhibition in January of this year. This visitors included the Egyptian Minister of Information and the chairman of NASA.
Flight 127 lifted off on February 17 with Ariane 44LP, successfully placing Superbird 4 on its GTO. And one of the most important cultural events in Guyana is Carnival, considered fourth best of its kind in the world. Arianespace made an important contribution in this event.
And a work in progress for enhancement of the CSG launch facility to cater for future Ariane 5 upgraded versions. And finally, we see some pictures of the latest tests of the Vulcan 2 main stage engine, also designed for future enhanced Ariane 5 versions at the DLR Lambolthausen plant in Germany. Returning to tonight's flight, we're going to show you a film summary of the preparation campaign for the Ariane 505 launcher, a campaign which lasted just 35 working days. The brand new carrier ship, the Colibri, arrives in the port of Pariacavo, Kourou, with the Ariane 505 launcher stages for flight 128. The main cryogenic stage is offloaded during the hours of darkness and transferred, passing close to the Jupiter 2 building, to the launcher integration facility on the ELA-3 complex. The main stage is destocked and raised to the vertical position, checked and moved to a temporary station alongside the launch table. The solid propellant boosters are brought up via the dual rail track for assembly in turn in the launcher integration building. We see a booster entering the building, where it is then moved forward on its pallet to the launch table in turn. With the boosters in place, the cryogenic main stage is lowered into its central position, and the vehicle equipment bay is placed on top of the main stage and integrated with the launcher. Finally, the storable propellant upper stage is brought over the launcher by the mobile gantry and mated with the main stage assembly. After a series of checkout procedures, Ariane 5 is ready to move on to the final assembly building to receive its passengers for flight 128, Insat 3B and Asiastar.
And we move on the first of our passengers on this flight with a World Space film, giving us an insight into this operator's activities in the context of the Asiastar spacecraft and its sister satellite Afristar, launched on Ariane in 1998.
Radio broadcasts are immensely popular in the developing countries. Combining the satellite and digital transmission will provide a quick way to deliver high-quality sound, a wide choice of programs, and easy reception. In 1995, the US company World Space selected Alcatel of France as prime contractor to deliver the World Space System under a turnkey contract. This will be the first worldwide digital radio broadcasting system to use direct satellite transmission. From now on, it is nothing less than a revolution for people in Africa, the Middle East, and tomorrow, Asia and Latin America, a revolution in the airwaves. As the head of an industrial consortium, Alcatel is responsible for overall system engineering and validation, including construction and launch of the 3 geostationary satellites, Asiastar, Afristar and Ameristar, designed for the mission. Launched in October '98 by Ariane, Afristar, the first satellite, is fully operational and today broadcasts tens of radio operator programs across the entire African continent. The 4 types of receiver are currently marketed in many countries. They offer crystal sound quality, but also the possibility of receiving multimedia information, such as web pages, or downloading communications files with a computer connected. Yesterday, Afristar. Today, Asiastar. With the World Space System, the radio operator of the 21st century makes a decisive projection. With Alcatel Space, it became a reality. Together, we bring more than technology. We bring life.
With the 15 minutes and a few seconds left to the start of our 47-minute window, our status panel continues to show us what we want to see. Time to meet
the Ariane payload manager for Flight 128, Patrick Loire, who is also Ariane Space mission manager for the Asiastar spacecraft.
And we shall be meeting, no doubt, yes, here we are. Who, in fact, do we have here?
And here we are at Rochambeau Airport in Cayenne for the arrival of Asiastar. The spacecraft is transferred to the payload facility where the container is opened. Asiastar is then connected to its integration jig and the operations can begin. This jig can be set horizontally or vertically according to the need. Here you can see it in its vertical position. The preparation and the electrical control takes about 1 week. After, the spacecraft is put into another transport container and taken to the S3 building for its fueling. Here, it will be filled with its propellant and oxidizer by technicians in safety suits. Then the combined operations begin. The spacecraft meets its flight adapter and transferred to the final assembly building, where it is put over the SIDA structure. The fairing is then closed, and a few days later, the complete upper composite is put on the top of the launcher. And the second passenger under the fairing tonight is Insat 3B, built by its operator ISRO, the Indian Space Research Organization in Bangalore. The ISRO film is coming up in just a couple of seconds.
Insat 3B is conceived to augment the communication capacity of Insat system, and we will have a few glimpses of the tests done on the Insat satellite. First, it has gone through the thermovacuum test, followed by the deployment test on the solar panel, and later on the deployable reflectors. And these are followed by physical measurements on the spacecraft. The satellite, after the physical measurements, which you are seeing now, will be subjected to the vibration test and later on the acoustic test to qualify the spacecraft for the launch environment. And this is followed by the fit checks to ensure compatibility of interfaces, and then it is transported to French Guiana in a special container, and you see the send-off, and it is transported in a special chartered flight to French Guiana to be launched on the Ariane 5 launch vehicle. The Insat 3B will be located at 83 degrees east together with Insat 2E, and will augment the Insat system by adding extended C transponders, KU-band transponders, and MSS payload. And this would be a significant improvement to Insat system space segment.
This is the seventh Ariane launch for Israel, and here we have in camera Jean-François Lemonnier, Arianespace mission manager for Insat 3B. And with a bit of luck, we'll see some members of the Insat satellite team in a few seconds. There we see Mr. Prad Rao, who is satellite preparation manager. Insat 3B was flown into Cayenne Rochambeau Airport from Bangalore, India, on a Boeing 747 cargo aircraft. The spacecraft was moved up to the Guyana Space Center payload preparation facility during the night. The container was opened and the pre-launch preparation process commenced immediately. This included deployment of the solar panels, a rare and impressive procedure but conducted systematically by Insat and accompanied by illumination tests, as also deployment of the telecommunication antennas like that. This was followed by a series of thruster alignment adjustments before transfer of the satellite to the fueling hall, where the fuelmen, kitted out in their autonomous spacesuits, carried out the propellant loading operations. On completion of this task, Insat 3B was prepared for integration with the launcher, commencing with assembly on its payload adapter. The spacecraft was transferred to the final assembly building in a special container and mounted directly on top of the launcher. Here we see the final docking maneuver. With Insat 3B in place, it was the turn of Asiastar, already mounted on the cylinder structure and encapsulated in the fairing, to be hoisted to the payload platform and lowered onto the launcher, completing integration of the upper composite and final Ariane 505 assembly phase. Well, while we were watching that last clip, Pierre Michele, you've been listening in to the final pre-launch weather report. So what's the situation?
Well, up to now we can say the conditions have improved from the situation over the last 48 hours, and we have clearance for the duration of the window. So we should have no problem there. And you can see that from the satellite image on the screen.
What in fact are the constraints which would have given us a Met status red, and are they exactly the same for Ariane 4 and Ariane 5?
Well, basically we have the same criteria for Ariane 4 and 5, that is to say wind conditions and electrical storm risk.
And what about the high altitude wind problem, which is at times fairly troublesome for Ariane 4?
Well, they still have the same problem for Ariane 5 as well. Even if the flight path is slightly different, the conditions are the same.
It is not, of course, a strictly Met problem. It is a safety problem, is that not so? What's that burning, those flames we see in the corner there?
It was the hydrogen venting pool.
And here we see a rollout of the Ariane 5 launcher. Would you take us through the sequence, Pierre Michele?
We are seeing the rollout was done yesterday. It takes about 1 hour for the 2.8 kilometer at a maximum speed of 6 kilometers per hour in steady state, and it is a manual operation.
And it's comparable with the rollout of Ariane 4 up that 1 kilometer of rail track, I would say.
Well, it's
moving a bit faster.
Yeah, it is.
And we come up to the final segment of the...
À tous de DDO, arrêt du décompte suite à rouge météo.
And we have
tous les
indeed...
moyens restent prêts pour le début de la séquence synchronisée dès le retour au vert.
And we have, in fact, to put it bluntly, a contradiction of what we just told you. We have a red on the status panel, a red for weather conditions. What the details are, I'm afraid we can't tell you for the moment. What we can tell you is that the count has stopped, and we hope that we shall be able to get going again within our 47-minute launch window for flight 128. So under these circumstances, what happens to the launcher? What happens to the satellite, if anything? Or do we have a time tolerance during which the status quo is maintained? Do we have a return to a safety state, or what is the position here?
At this moment, all the launcher and the spacecraft are ready to enter the synchronized sequence, which is the final 7 minutes totally automatic sequence. So they are always ready, and as soon as the green light will be shown, that is to say we have all the meteor criteria to go on, the sequence will start.
So we did not, in fact, have any changeover of control. The launcher is still under human operator control in the CDL. Is that correct?
Yes, it is. And at this moment, they are going on with the topping up of the two tanks, hydrogen and liquid oxygen tank, to maintain the right level and pressure for the flight conditions. And they can go on like that for quite a lot of time, until at least the end of the window.
Right. We have a reasonably generous window tonight of, as I said earlier, 47 minutes. Of which, obviously, 7 will be absorbed by the synchronized sequence when we get going again. Less any time that we now absorb of the 40-minute margin.
Yes, because you must remember that if we have by chance any stop during the synchronized sequence, in any case we have to go back to the -7 minutes to restart.
Indeed, we would have had exactly the same result had we slipped into the synchronized sequence by 30 seconds, couple of minutes. We would have moved back to
That's it.
The current state.
In any case, you have to go back at -7.
Well, as we stand, I'm afraid we have absolutely no indication of the nature of the meteor problem. c'est bon. Bon, nous voilà de retour. Les dernières nouvelles dont nous disposons, c'est que... Sorry, we got switched onto the other channel there. We're now back with you, and the latest news is that hopefully we shall get rid of that Met Red in some 10 minutes from now. But don't be alarmed as and when that happens to see another red come up for one of the satellites. That is purely a technical resynchronization precaution. Perhaps you could explain a little more, Pierre-Michele.
Yes, in fact, we had stopped the countdown, so one of the two spacecraft, Asiastar, will ask for a 2 minutes resynchronization as soon as we have the conditions to 1 ton. So you will see on the screen a red on the Asiastar status, which does not mean that there is any problem. It's just a timing before the launching of the final synchronized sequence.
And that apart, we'll just ask you to wait patiently until we get going again. In fact, while we're waiting, we can now tell you exactly what the weather problem was. It was an electrical storm risk at fairly high altitude and not particularly close, but when you're launching a...
À tous de DDO, retour au vert météo. Attention pour le début de la séquence synchronisée.
And we're back and almost running. And
H0
we're
moins 7
into
minutes.
the synchronized sequence. And as we warned you, we are likely to have another red for the Asiasat satellite before we finally get off. Though if that has been bypassed, so much the better. Anyway, let us carry on as if nothing had happened. We're inside the synchronized sequence, and control has changed from human hands to the ground computer. So how do we take that?
Yes, we are in this completely automatic phase where no human intervention is taken to bring the launcher to the flight configuration.
In functional terms, the design of Ariane 5 is simpler than Ariane 4. The cryogenic
tous
main
de DDO,
stage has been
la résumé
validated
compte
by the
suite à un
partnership
rouge en
of
forme de
MQ
lancement.
tests in French
Tous les
Guiana,
moyens restent prêts
followed
pour le
by
début de la
qualification
séquence
flights
synchronisée dès le retour au
502
vert.
and 503, and is now functionally mature.
Cet étage est mature au niveau opérationnel.
As for the EPS storable propellant stage, we've not encountered any operational problems so far. Integration of the Ariane 5 electrical and logistics systems using checkout facilities identical to those for the fluid systems involves substantially fewer constraints than previously encountered on the ELA-2 complex. The solid propellant boosters are assembled, filled and acceptance tested in French Guiana, and we've had very little work to do in this domain. This means that the objectives set by Arianespace management for shortening the launch campaign are focused, first and foremost, on improvement of the launcher's mechanical assembly procedures and definition of its thermal protection systems. We're also engaged on defining automatic fueling systems for the storable propellant stages. The aim is to complete Ariane 5 storable propellant operations in a single day. Accumulated experience with operations in the launcher integration and final assembly buildings will enable us, through more efficient coordination and clearer identification of the constraints involved, to cut back the launcher campaign over the next 4 or 5 launches from the current figure of 35 days to around 30 days, and in due course to 25 days and less. Substantial construction work is in process on the ELA-3 site. This will cater for the future Ariane 5 cryogenic upper stages, and in particular we shall be introducing numerous modifications between successive Ariane 5 launches to the various buildings concerned and on the launch pad itself. The resources applied and actions initiated today will enable us, with a second launch table and an optimized launch campaign duration, to obtain the launch capacity we possess now with Ariane 4, namely a launch interval of no more than 3 weeks, and to achieve an annual rate of 8, 10 or even 12 launches with Ariane 5. Well, I'm sorry, folks. We warned you that there was going to be another red, but and we've got one, but it's not the one we expected. So what can we tell our friends straight off the bat while we wait for something more precise, Pierre Micheli?
Yeah, we are ready for more information. There is a red concerning the launch complex.
And the only information we have had actually in the cabin is that we're waiting for news from the Launch Control Center, the CDL. And once again, I'm afraid we're stuck for cogent information to pass on to our listeners.
And as you can see on the screen, the countdown went automatically to -7.
That is so. In fact, we stopped on a figure of something under 6 minutes, if my memory serves me correctly, and subsequently switched back, as is standard procedure, to the 7-minute mark, which once again means that of our remaining window, 7 minutes will be absorbed by a new synchronized sequence as and when we get rolling again.
But the good news is the meteor criteria is green.
Yes, well, one must always look on the brighter side of things, as they say.
You're right.
Is there any difference in the current situation with the launcher and the satellites between now and when we had our first red?
No, we can consider we are exactly at the same situation, since the flight parameter to enter the synchronized sequence are fixed. So at any stop, we went back to this configuration.
And when one goes back from somewhere in the middle of the synchronized sequence, is there any process that has to be reversed? Is there any condition that has to be wound back, should we say?
Well, the synchronized sequence is a very complicated program with a lot of sub-sequences taking back the launcher to the -7 configuration, ready to restart. So it depends actually at what moment you stop the sequence, and for which reason.
Yes. Well, one obvious example would be either the satellite and or the launcher having gone on to onboard power. If we then got a red and switched back to 7 minutes, they would go on to ground power again.
Yes, it is.
Presumably.
At the beginning of the sequence, everything is on the ground power. So if, as you said, the red happens after, when you already switched on the board, you went back to the ground power for all the systems.
Right. And as we shall see when we get going, the launcher switches to onboard power at just about 1 minute from time t, and under normal circumstances the satellite or satellites switch to onboard rather earlier than that. What is the explanation there?
Well, for the launcher, it is a fixed...
The last possible moment.
The last possible moment, because we are in training. We are making a lot of active sequences, final pressurization, chilling the engine, and so for the satellite we are in a quite steady state configuration, at least from a fluid and pneumatic point of view, not for the electrical. So you can take the electrical switch on board power some minutes before.
Right. Have you got your stopwatch running? Can you tell us how much of our window is left? I'm afraid I've missed out on that one. By the feel of it, I would have said we've been running about... Just for a moment, we have some information coming in.
Tous de DDO, rouge de la charge utile Asiastar pour retour en configuration pour préparation de la prochaine séquence synchronisée.
Well, in fact, we've now got, as you will notice, 2 reds up on the board, and the second one is the Asiastar technical resynchronization red that we mentioned earlier. So now we've got a real handful. We've got the one we promised you, plus a bonus, not really, for the launch site, which can relate to the launcher itself, of course. Well, we have something to tell you this time. As you'll see, there are still 2 reds up there, and unfortunately, we have a potential third. We have, allowing for a restart of the synchronized sequence, something slightly less than 20 minutes of our window left, but we now have the threat of a Met problem, namely the one we talked about earlier, the electrical storm risk. So we're not dead yet, but it's not looking particularly promising for liftoff tonight. Anyway, we will keep you posted as and when we get any clarification, any further news on that. Once again, Pierre Michele, any change in the situation regarding the launcher and the satellites?
Up to now, any change. The launcher will be until the very last, hopefully, useful minute to start the sequence in the same ready-to-flight configuration.
Mm-hmm.
If we have not the possibility to start the sequence tonight, the reconfiguration operations will start to start the unloading of the 2 cryogenic fuel and oxidizer.
Retour au vert de l'ensemble de lancement. Tenez-vous prêt pour le démarrage de la séquence synchronisée dès le retour au vert de la charge utile Asiastar.
Right, well, this is a very changeable situation because, as you have already seen, we have killed the red for the launch site. We are going to make an attempt to get into the synchronized sequence again, just as soon as the Asiasat technical red for the resynchronization has itself disappeared. One minor correction, I referred just now to Asiasat. My apologies to the Asiastar team from top to bottom. So we are now all waiting for probably something not much more than a minute while the resynchronization is completed before we go into the synchronized sequence. And
à tous de DDO, retour au vert de la charge utile. Attention pour le début de la séquence synchronisée. Top.
And we're into the 7-minute final slot.
Le nouvel H0 est 23h28 19 secondes TU.
And that is the announcement of the revised H0 or time T ideal liftoff time. And all we need to know is that as things stand, it is just over 6.5 minutes from now. So we're up and running in the synchronized sequence, and I think we might just as well continue where we left off with your explanation of the change in the control situation which has now occurred.
Yes, Simon, now we are in the synchronized sequence, and in these moments we are having the final pressurization on the liquid oxygen and the hydrogen, and soon the launcher will be isolated from the ground in its final flight configuration, both from the fueling and the pressurization. The synchronized sequence is not really just one program, but 2. One for the electrical systems, the other for the fluid and pneumatic ones, both running on the same computer system. This is one of the main improvements with respect to the Ariane 4.
Where there were, of course, 2 self backing up ground computers.
Yes, 2 different computer systems, one just for the fluid and the other for the electrical. This was because the 20 years ago technology, of course, was not the same as we have now.
Indeed. Which is not to say that we don't have 2 computers now, but only one is operational and the other is there on backup.
Any computer system on the Ariane Launch Center is redundant.
Of course.
So there is an automatic switching from the main computer to the backup one, but it is just one computer system.
Right.
Which is called the operational command and control.
Right, now, if you all look top right of your screen, like we're doing, there's some flames.
Yeah, they are the impressive flames of the hydrogen venting line coming from the pool. It's like a swimming pool, but not very good for swimming. Mostly about 40-50 meters, the height of the flames you can see on Ariane 5.
Right.
Yeah, it is used to burn the gas hydrogen coming from the topping up and from the venting lines, because the hydrogen is boiling really inside the tank. So we had to vent the pressure outside, and since it's quite a dangerous gas, it has to be burned.
And Rémi Cochet, the mission director, looking perhaps a little more settled than earlier on.
Patrick Loire again.
Jean-François Lemonnier. So we are now halfway through the 7-minute synchronized sequence. And what about the ground stations? What what were they doing? What was their position during those series of reds? When we were coming up to the synchronized sequence initially, they were obviously on full alert and had been for some time. Did they go into a special hold situation, or did they just sit and wait like we've been sitting and waiting?
Well, they are ready for their task tonight, and we did not see any red from their side, so all the telemetry render station down, they are just waiting for the... Well, of course, they received the resynchronization of the estimated liftoff time, so they know that we are a little delayed the liftoff.
Right, well, before we go any further, perhaps a quick rundown of the final events in synchronized sequence, Pierre Micheli.
Yes, so we have still 2 minutes and 20 to go. Almost everything has been done on the fluid and the pneumatic part of the launcher. At -1 minute, as you said, we'll have the launcher onboard power and some electrical and pyrotechnical activity like the launcher final arming for liftoff.
And perhaps a quick rundown on the ignition sequence while we've still time to get our description in.
Well, the ignition sequence of the Vulcan engine is the real final part of the synchronized sequence. But first, you will see at screen the ignition of the chilling burner just down of the nozzle. And then we have the real Vulcan engine ignition. First with the chamber igniter, after the turbine starters, and finally the gas generator igniter. Well, these three events are almost synchronized at the same moment.
And as we approach the final minute, a good moment to give a reminder for very latecomers. You're just in time to catch Arianespace flight 128 with Asiastar and Insat 3B on board Ariane 505.
À tous de DDO, attention pour H0 moins 1 minute. Top, H0 moins 1 minute.
And we have less than 60 seconds to go. The launcher is on onboard power. Tense moments these, very tense. Having absolutely nothing to do but wait doesn't altogether help. We've just time to wish both satellite teams the best of luck, a good launch, successful injection into GTO and acquisition of final orbit. And we'll leave it now to the DDO. We'll be back as soon as we have ignition.
À tous de DDO, attention pour le décompte final. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Allumage.
We have ignition. We
Allumage
have
des
liftoff.
étages accélérateurs et décollage.
And we have an impressive light.
Tous les paramètres de propulsion sont normaux.
And we're into the tilt and roll maneuver
Trajectoire
already.
normale. Tous les paramètres de propulsion sont normaux.
Completed. We have no picture because of the cloud, but we can tell you that now, as of this second, Ariane is supersonic.
La trajectoire est normale, les paramètres de propulsion
We're
sont normaux.
getting regular announcements from the DDO on launcher status. Everything is strictly nominal on board. At a later stage, we'll tell you how he gets this information, where it comes from and how it's processed. And we're getting intermittent glimpses of the launcher, and here in Jupiter we have a hell of a racket up top as Ariane is almost overhead. Wow. I should imagine you can probably hear it on the viewing sites.
Trajectoire normale. Paramètres de propulsion normaux.
That struck me as being much louder than when I was in the commentary box for flight 503. But anyway, now I think it's time to give you a description, an explanation of the display on your screen. Pierre Micheli.
Yes, on the screen, on the left bottom, you can see one curve. This is the theoretical and ideal trajectory of the launcher, and the little dot or cross you see moving on the trajectory is the real position of the launcher coming from the radar and telemetry data. So we can see it's exactly over the expected curve, and this means everything is okay, the launcher is on the right path.
And in fact, the display is confirmed by the DDO, who announced a strictly nominal trajectory just a few seconds back.
Séparation des EAP.
And we have separated the two boosters. We'll explain the process later on. And on the right of the screen we have a data panel.
Trajectoire normale.
On the data panel we can see the altitude and the speed of the launcher. At this moment we have almost 90 kilometers altitude and more than 2 kilometers per second speed.
Tous les paramètres de propulsion sont
After
normaux.
we have the time, 186 seconds, and also the telemetry we are using, that is the nominal inertial platform.
And it is noticeable how much faster than any
Séparation de la coiffe.
And we've just dropped the fairing, 2 tons of now superfluous mass. We reached this
Tous les
separation
paramètres de
point
propulsion sont normaux, la trajectoire est normale.
much earlier than with Ariane 4, but the more than a minute ahead. The point being now that the fairing is no longer required. Why precisely, Pierre Micheli?
Because both on Ariane 4 or 5 we are trying to get rid of everything is not useful for the flight. So at a certain altitude and speed the aerothermal flow is very, very little, and satellites no more need the protection for the atmospheric flight.
And we're now 4 minutes into mission. 135 kilometers up and velocity heading up for 3 kilometers per second with our ultimate target of very nearly 10. In fact, as you'll learn later in the broadcast, our orbit injection point, the perigee of the transfer orbit, is substantially higher than for Ariane 4 that you're accustomed to. Is the velocity the same, 9.7, or is it...
It will be slightly different because the position is higher. But anyway, what is the most important thing with respect to the Ariane 4 GTO orbit is the higher perigee, as you said.
which represent an advantage for the customers.
Tout à fait normaux.
Yes, because this means that this GTO orbit will be more energetic, so the satellite itself will have to spend less power to circularize and put itself over the final geosynchronous, and which means either to put more payload and less fuel, or to have a longer life.
Simply because the fuel on board the satellite is used principally for station acquisition and subsequently station keeping.
Yes, of course.
Countering the various factors which are constantly trying to push the satellite off its orbit station. What in fact are these? What are these negative forces that are working on the satellite?
Well, there are different kind of negative forces, as you said.
Trajectoire parfaitement normale.
The influence of gravity and the solar wind, which is not zero, of course, and all the particles which still in space vacuum exist. So all these effects have the power to move the satellite from its ideal position.
So you're saying that a tiny particle can push a multi-ton satellite off its orbit position?
Yeah, because they are very tiny, but they have an enormous speed.
Yes.
And so the energy, the kinetic energy, is very high.
One point we should perhaps make clear to some of our viewers, we talk about an orbit station, and it can be imagined that that is a point in space which corresponds roughly to the volume of the satellite. That is not the case. The orbit station for a geostationary satellite is a cube measuring, wait for it, 70 by 70 by 70 kilometers. That may seem large, but at 36,000 kilometers altitude, it's a pinhead, really.
Trajectoire normale.
And we're still getting encouraging announcements from the DDO. And perhaps this is the moment to explain to you how the DDO gets its information, which is obviously, as you will have guessed, beamed down from the launch itself. And we have acquisition by the Natal downrange station, which is the first.
Tous les paramètres de propulsion sont normaux.
Is it the last radar station or the first telemetry only station?
The last radar one.
Okay.
The next station, Ascension, will be just telemetry.
Telemetry, and after that we have Malindi, and we shall give you the acquisitions and loss of signal as they occur, and explain the overlap in each case, because the launcher, apart from the final phase of its
Il reste un peu moins de 100 secondes de propulsion pour l'étage principal.
Is always, yes, Pierre Michele points out that we are approaching the end of the cryogenic main stage propulsion phase. We have in fact now less than 1 minute to go.
Yeah, you were talking about how the DDO gets the information about the trajectory, in fact.
Paramètres de propulsion normaux et stables.
I think perhaps we'll save that until we've got over this fairly complex shutdown, separation and ignition phase, because this is a key moment in the flight.
Almost 1 minute left.
Trajectoire normale.
For the EPC propulsion.
And something else that you will all have noticed is that the whole flight pattern is entirely different. The burn times are very substantially different.
Il reste 30 secondes de propulsion pour
30 seconds to go for shutdown of the main cryogenic stage.
Fin de visibilité normale des moyens de Kourou.
Loss of signal by the local tracking stations.
Extinction de l'étage principal cryotechnique.
Burnout of the main
Séparation
cryogenic
de
stage.
l'EPC.
Separation okay.
Allumage de l'étage de propulsion ergol stockable.
And ignition of the upper stage engine, the storable propellant engine. We have a computer replay here. And there we see computer confirmation of that ignition. The moment, I think, Pierre Michele, to explain what is now happening at this moment to the main cryogenic stage, that huge cylinder.
The EPC, the main
La
cryogenic stage,
trajectoire est normale.
has been separated from the upper composite and is falling down back to the Earth, but we want to avoid it to fall in a lifting way, which could be not the best way to re-enter in the atmosphere.
But in fact,
So we are seeing the computer simulation of this rolling maneuver, which is caused by a pyrotechnical device opening a little nozzle on the hydrogen tank, venting. This
Trajectoire
put
tout à fait normale.
the stage rolling during its entering in the atmosphere. This way we are sure it will burn out.
and of course the twisting motion is will ensure that there is no bounce when it hits the heavier atmosphere, and certainly won't bounce back in our faces here in Kourou. Mind you, it's got a long way to bounce if it does, but it's a safety precaution in the truest sense of the word.
It is. In fact, you want to avoid that this almost cylindrical body has a lift during its re-entry trajectory. This way you are sure that it will not bound over the atmosphere and fall down into the Pacific Ocean. Not far, not very, very far from the South American coast. So we can see the...
What sort of distance are we talking about?
Not very far, means several thousand kilometers
Acquisition
anyway.
par la station d'Ascension.
We have acquisition of the launcher by the Ascension Island, and there we have the...
Tous les paramètres de propulsion sont normaux et stables.
Everything on board is strictly nominal. Some pictures of Ascension Island, and we also saw the overlap simulation. We are now approaching 13 minutes intermission, and we're well into the very long burn time for the upper stage engine. A total of some 17 minutes, I think we said.
Yes, it is about 17 minutes, the burning time, even if the thrust is not very big, just around 3 tons thrust, but
fact,
quite a long...
I would say we're just about halfway through total burn time for the Ariane 5 launcher there at 13 minutes and a bit. A check on the data, we're at 280 plus kilometers, and our speed is approaching 8 kilometers per second, which just goes to show what a power pack the main stage and the 2 boosters represent.
Trajectoire normale.
So perhaps
Il reste 13 minutes de propulsion pour l'étage à ergol stockable.
and the DTO has just confirmed that we have 30 minutes of burn time left for the main stage. That last protractor-like image was pointing the way to the final launcher mission downrange station in Malindi. We're accustomed to seeing a pickup by Libreville after Ascension Island, Pierre Michele, but why have we leapfrogged over there? Is it simply that the actual trajectory is substantially different?
Yes, the trajectory, the flight path for Ariane 5 tonight is very different from an Ariane 4-1. So we want to have a telemetric coverage of all the flights, and there is no need to shift from the Ascension to Libreville tonight, because Malindi will have inside the launcher before the Ascension ground station.
Fin normal de la
Distance and
poursuite par la
altitude.
station de Natal.
It's just a confirmation. It's a problem of visibility from the ground.
Right.
So we are much higher than Ariane 4, sorry, more than 300 kilometers
And
now.
in fact, the whole curve is different, is it not? There's no dip that we always remark on. There's no slingshot effect in the
Trajectoire
same
tout à
way.
fait normale.
No, this is not. That was a particular maneuver for the third stage Ariane 4.
Right. Well, third stage makes one think of third stage of Ariane 4 makes one think of cryogenics, and
Il reste 11 minutes de propulsion
We
pour
have,
l'étage à propergol stockable.
already pointed out that the main stage, the main cryogenic stage of Ariane 5 represents, in fact, a reversal of the whole propulsion system compared with the predecessor Ariane 4 and the earlier Arianes. Now, why? Why have we changed everything round?
Yes, in fact,
Trajectoire tout à fait normale.
we can see that Ariane 5, with respect to Ariane 4, has a completely different modular concept. On Ariane 4, you have a main core with storable propulsion on the lower stages, first and second. And Ariane 5, the lower composite is fixed, one cryogenic main engine plus 2 solid rocket boosters, which is a very good configuration and optimized for instance, low Earth orbit
Il
missions.
reste 10 minutes de propulsion
On the
pour
top,
l'étage
we have
ETS.
a storable upper stage, which has really nothing to do with the storable stages we have in Ariane 4, since it is a simpler technology, cheaper, more reliable, and even the fuel is not the same. It's monomethyl hydrazine. That is to say, more like a satellite engine than a launcher one. And why a storable upper stage? Because the fuel and the oxidizer are hypergolics, so it's very easy to make it reignitable, and this gives Ariane 5 a good versatility for future missions, long ballistic phase, and different reignition in orbit.
Right. Because let us not forget that Ariane 5 is still very young. Ariane 5 is still in its basic initial
Trajectoire tout à fait
qualified
normale.
version, and there is a lot of development work going on already.
Il
Yes,
reste 9 minutes de propulsion.
we have a different level of development. On the lower part of Ariane 5, we have some improvement on the main engine. The Vulcan 2 engine will
As we
reach,
saw the pictures of the Lambertshausen test rig.
will reach more than 140 tons. We'll have some improvement on the structural part of the solid rocket booster, but the main one maybe will be the possibility to have different kind of upper stages for Ariane 5. The EPS, the storable one, which is flying tonight, and in a few years a new cryogenic
paramètres de propulsion sont
stage
normaux.
called the EEC, with an engine taken from today's Ariane 4 third stage. And at the end, in about 6 years, a brand new cryogenic stage with a new engine, which will be reignitable as well.
Yes. That is obviously a very important feature in future major mission applications, geostationary and further afield, of course. One point that we haven't really covered is the fueling up of the launcher. I know we've been flying now for nearly 20 minutes, but once again, for people making acquaintance with the new launcher for the first time, the differences with Ariane 4, to which they've been used for so many years, are considerable. A little rundown on how we fuel Ariane 5.
Of course, Ariane 5, the main cryogenic stage, is has the same fuel and oxidizer of the third stage Ariane 4, but since it's the lower one, its interface with the ground are on the launch table, so it's filled from the bottom, really. And this is the reason why we don't have any cryogenic
You might say
arms.
that it has a form of a suppository type fueling system, if you wish to look at things
not
that way.
very kind for the cryogenic stage, but you can say that. Anyway, it's a very reliable way of refueling, because you don't have any moving part like we had to have on Ariane 4 third stage.
Well, I'm sure some viewers will have been disappointed not to have seen some cryogenic arms and not see them open on this occasion, but
we will see in a couple of years.
True.
And even for the storable stage, we have a completely different fueling procedure, since the EPS, as I said, has really nothing to do about the storable stage we used to have at Ariane 4. And it is fueled more like a satellite, starting with the tanks in vacuum. After we have some particular procedure to avoid gas bubbles inside. This to allow the capability of the reignition into orbit. And we must not forget the smaller and the smallest, but the longer fuel system, which is the attitude control system in the VEB.
I'll just cut in there on behalf of the DDO, who's given us a further announcement that everything is again strictly nominal at a point in time where we must be about 5 minutes from shutdown of powered flight for 505.
Il reste 5 minutes de propulsion sur le PS.
I wasn't far off. 5 minutes of burn time left.
And in this phase as well,
acquisition par la station de Malindi au Kenya.
And there we have, this is the first time I've had the pleasure of announcing acquisition of an Ariane launcher by the Malindi downrange station. On earlier launches, Malindi was often the first pickup for the satellite after separation. Before Ariane 5, this is. But the Malindi station was not a tracking station for the launcher.
Tous les paramètres de propulsion sont normaux et stables.
Not normally, at any rate.
Normally not,
no.
But it has already been used for some...
Et la trajectoire
missions.
est normale.
So we are now some 4 minutes from shutdown. Shutdown of the upper stage engine, and sooner or later we should have a computer-assisted sequence for
normal de l'acquisition par la station d'ascension.
For the separation phase, starting from shutdown of the upper stage engine and spin up, separation of the first satellite, and so on. Whether we shall finally have that remains to be seen. Before we get any closer to actual separation of the satellites, I think we should come back for a moment to our payload customers. Insat, the Insat program dates back to 1993 with a first spacecraft designated 1B. Note that the tradition seems to persist because Ariane is launching Insat 3B ahead of 3A on this occasion. The satellite program is headed by the Indian Space Research Organization, ISRO, and we have still strictly nominal conditions on board the launcher. And ISRO works very closely with the Space Application Center in Ahmedabad, the Liquid Propulsion System Center in Bangalore, the Vikram Sarabhai Space Center, and the ISRO Inertial System Unit. How many was that?
2 minutes
Two
left
minutes.
for the upper stage.
Right, so we're getting very close, and I don't think we're going to have that computer-assisted sequence, but anyway, we'll explain what happens with or without computer assistance when we get there. Insat 3B is expected to make a major contribution to the wider use of VSAT terminals, of which some 7,500 are currently in service in India. Asiastar team members there, top left of your screen.
Trajectoire tout à fait normale.
Looking anxious, but perhaps a little impatient.
Il reste 1 minute de propulsion.
One more minute of burn time. The flight command cell in camera top left, they have had nothing to do this evening, fortunately, though they might have done with that that bundle of reds we had before we finally got off. 30 seconds to go for shutdown. The Insat team. They could all be forgiven for having thought earlier this evening that they would not get to this point tonight. And we have shutdown of the EPS, storable propellant, upper stage engine.
Début des manœuvres d'orientation.
And we start I think you take it from here, Pierre-Michele, with...
And we are seeing a computer simulation of the attitude control system, Ariane 5, orienting for the first spacecraft separation.
And they're not persisting. We should have had the full sequence before we got here so that we could have talked about it in detail, but we'll just give it to you bit by bit. But what in fact is happening now, we're coming very close to first satellite separation. We are spinning up, is that correct?
It is. As soon as the attitude control system puts the satellite in the right position, it will start a rolling movement to make the right spin before the separation, and this in a stabilizing task.
This is stabilizing the satellite before it can do it for itself. Is that correct?
It is. In a few seconds, normally.
Séparation Asiastar.
Right, and there we go. Asiastar now in autonomous.
Début de la deuxième manœuvre d'orientation.
Transfer orbit, and again, Pierre-Michele, pick it up with the
after the separation
continuation of the SCAR maneuver.
Of the upper spacecraft, we have a spin on the opposite way to reposition the lower spacecraft in the right position for its separation, but before we have to separate the SILDA structure,
right,
which we should see on the screen in a few minutes. This structure, which is the Ariane dual launch system, allowing Ariane 5 to put two spacecraft.
Acquisition confirmée de la TM Asiastar.
And we have
de la télémesure Asiastar.
And we have initial confirmation of acquisition of telemetry signals from Asiastar, now independently in orbit. Good news for the Asiastar team.
Manœuvres d'orientation se poursuivent normalement.
The orientation maneuver goes on nominal.
So the next event will be separation of the SILDA in how long now? I see you have the figures in front of you.
In about 1 minute and a half.
Right.
We'll have the separation of the SILDA structure, which will allow Insat 3B to separate a few minutes later.
And looking at the data column, we're at an altitude of over 2,000 kilometers.
Fin de la deuxième manœuvre d'orientation.
The second orientation maneuver is finished, so we are ready for the SILDA separation.
So there is no comparison between the altitude at which we shall separate Insat, a geostationary satellite, from the equivalent with Ariane 4.
No, because as you said, the ignition point is 560 kilometers instead of little more than 200. So we are now in the ballistic phase at almost 2,300 kilometers and in a much higher orbit.
We're 31 minutes into mission, so how do we stand for separation of Insat, who are Insat team waiting patiently, perhaps rather envious of the Asiastar colleagues who've...
Séparation du système de lancement double Ariane.
Right, we have separated the SILDA, as demonstrated so
Début
clearly
de la
by
quatrième
the
manœuvre
computer.
d'orientation.
And we go for the fourth orientation maneuver to put Insat 3B in its right position for separation.
And in, what, three minutes or so from now, we shall have separation of Insat. Same procedure as for the first payload. The release of the clamp band system, which literally clamps the lower flange of the spacecraft to its adapter. And when the moment comes, the two pieces of the clamp band are separated by pyrotechnic cutters. The two parts spring apart and are caught by catchers so they won't spring back and impede the separation. And the spacecraft is finally nudged gently away by a set of springs. Did I say that right, Pierre Michele? You were looking a bit doubtful?
Perfect. I can think you could make a very good technical consultant.
So we're at 32 minutes, 33 minutes coming up in a few seconds, and we're targeting, what, 34 for separation?
Less than 2 minutes normally before Insat 3B separation.
Well, I don't know about you, but the whole process is much longer than, once again, comparing with Ariane 4. But it hasn't seemed all that long to me. Is it to you?
Well, it really depends on the mission.
Yes.
It is longer because it is not the same altitude, not the same orbit, so you can't not really directly
La
compare.
manœuvre d'orientation se poursuit normalement.
The orientation procedure is continuing absolutely nominal. And I'm sure those watching from Bangalore will be as pleasurably anticipating the separation of their satellite in just a few moments as those here in the Jupiter building and those in the satellite control rooms in both the Technical Center and the CDL.
One minute and a half before separation, and the attitude control system now is the last fluid system working on which rests of the launcher.
Right.
Because differently from Ariane 4, it is not just gas venting from the third stage, hydrogen tank. Here it's a completely separate system.
Séparation Insat 3B.
Good, and now everyone can Ridley let go. So the orbit injection mission has been completed with the release of the second satellite, Insat 3B. The Ariane mission is not entirely completed because we have two major operations to complete: passivation and distancing, safety measures, both. But the real moments of excitement have now been completed. Congratulations now, and no doubt cigars in a few moments. And a few moments after that, we shall have the speeches, preceded also by at least one launch replay. So that, ladies and gentlemen, was Ariane flight 128 and Ariane 5 launch 505.
The first dual launch.
Indeed.
And the first
a big moment for all members of the Ariane 5 development and operational. And why not? And why not? A big moment for them both, and for all of us, in fact.
And Noah Samara, I am very pleased to announce the success of today of this flight 128, which is the first launch of Ariane 5, which totally demonstrates the configurations which will be used in the future. So it's a pleasure for me, Dr. Castro-Jungen, to give you this success after 8 launches where we were together on Ariane, and thank you very much for your confidence, and thank you to everybody for the success we have done today. Benoît Tellier, I know how it's important for you the success of tonight and the success of Ariane that you are going to support for a long time, because you will have for Alcatel a lot of launch that you give confidence to Ariane, and thank you very much for this. So, Noah Samara, I know how much your challenge is going very well. You have made a Freesat last year. You are doing Asiastar this year.
Yes.
And I hope it will be a big success for you and for your company. So I should like really to give you, all of you, all the maximum of luck for the future operations. Thank you very much.
Thank you, Jean-Marie, for your kind words. Ariane Space, you have done it again. That was the longest 35 minutes I experienced ever in my life. And an Insat is born, a new Insat. It was a beautiful takeoff, a majestic flight. The trajectory virtually hugged the predicted path. Nothing could have been asked for, more could have been asked than this. And we are extremely happy that the Ariane vehicle, the Ariane 5, the latest of the transportation systems that the Europe has developed, has placed the latest of the Insat, the first in the third generation, the Insat 3B, into the required orbit. I'm also happy to announce that the first signals have been received at the master control facility at Hasen. The